For topic 2, we're going to be talking about lines. To graph a line, they come from a linear equation. And our essential question for the entire chapter 2 is, why is it useful to have different forms of linear equations? So the first one we're going to talk about in section 2.1 is called slope-intercept form. And our essential question says, what info does slope-intercept form tell us? Well, slope-intercept form, if I jump ahead here for a second, is the form y equals mx plus b. The m is the slope, and the b is the intercept, specifically the y-intercept. Now, you may have seen this before. The sign that goes with the b is very important. So if you would have a plus or a minus sign here, it's important to include that. And slope always goes in front of the x. It's the number in front of the x, not the x itself. So that's why it's called slope-intercept, because we can see the slope in the value right before the x, and the y-intercept, that is the place where it crosses the y-axis, as the last value here. So if we were asked to graph an equation, so here in example 1, we're given the equation y equals 4 over 5x plus 2. We are starting with an equation in slope-intercept form, and we're asked to graph it. We need to identify the key features. This 2, or positive 2, is our y-intercept. This 4 over 5 is our slope. Now, 4 over 5 might be concerning, but we'll talk about that here in a second. If you were to ask which one's more important, or what one do I identify first, the y-intercept is the first thing you want to find. It gives you a place to start. So a y-intercept is found, and we know it's a positive 2. We would write that as 0, 2 in a coordinate form. That means when I come over here to this graph on the y-axis, I find at 0, I go up to a positive 2. That is my anchor, my starting point for the line. Then, my step 2 is to find the slope. Well, I don't have to do any work, but I do notice that the slope is 4 over 5. You may have heard before, slope is also known as the m value, as it was seen on the other equation on the last page. Or we also refer to it as the rise over run. So while fractions can be frightening, they're actually helpful when it comes to slope, because we will start at our 0, 2 and rise 4 steps, as well as run 5 steps and put a dot. Note that I didn't rise 4 and put a dot and over 5 and put a dot. I actually use the combination of rising 4 and running 5 in the positive direction. Now you could do it again and keep going on until you run out of graph. I could even go backwards. If I go down 4 and left 5, I find that point is also in the same line. Connecting these points, and 2 would be plenty, creates the line. However, sometimes we might ask you to go the other way. Let's just first look at these 2 quick examples though. My y-intercept is negative 3, so I would plot it here. And my slope is rise 2 over run 3. Rise 2, run 3. There'd be my first line. My second line is y-intercept of negative 3. And my slope here, notice that I have a negative 3. There's no fraction. At first we thought they were frightening, but now we see we would actually like a rise over a run. When you don't have a run, you have to put a 1. That's because 3 divided by 1 would stay the same. It would still be, or in this case, negative 3 divided by 1 is negative 3. So I start at negative 3 for my y-intercept here, which I did over in black. They have the same y-intercept. But now I'm going to rise a negative 3, which is like falling, and run a positive 1. Now, you might be saying, you fell down 3 and went over 1. Another thing I could have done was go up 3 and go left 1. This is my run. So if I go up 2, 3, and go left 1, notice how it lines up in the same formation. So if you ever have a negative in front of your slope, it's important to note that it will go down to the right, Okay, here's our negative. This is a negative slope, as opposed to this is our positive slope. And 0 down here is a flat line. Finally, another slope would be undefined if it goes up and down. So in our last example, we had one positive sloping in the pink and one negative sloping in the black. Lastly, you may be asked to take a graph and make an equation. So if someone wants a slope-intercept equation, that means they want it in y equals mx plus b form. Well, just as it was easy and we needed to focus on the y-intercept first, we're going to go find the y-intercept of this blue graph here. It is crossing the y-axis at a -4. So my b value is -4. I've actually found the end of the equation first. My slope, this can be a little tricky. You don't want to find a point that's kind of halfway between things. I know for sure it's crossing here. So my slope would be up 4 and to the right 6. Notice how I'm going up and right, so they're both positive. My slope could be written as rise 4 over run 6. Now to finish my equation, there's always an x and there's always a y equals. That would be my slope-intercept form. However, you might see it written as y equals 2 over 3x minus 4. Think about it. 4 and 6 are both divisible by 2. 2 goes into 4 2 times, and 2 goes into 6 3 times. If I come to the graph, I'll be able to see that I could have started here and gone up to over 3 and had a more reduced slope. Either way, you need to be able to find a y-intercept on a graph, draw your little slope triangle and do your rise over run, and put it in a slope-intercept equation.